Hello everyone. As part of learning Big Data Hadoop framework, we will be learning today Hive, which talks about how do we store huge amounts of data, how do we maintain the data, huge amounts of data in this warehouse. So, we will be talking about Hive as part of this course. So, it was created to make it possible for analysts to work with the entire huge amounts of data just as they are dealing with SQL like databases. Now, when they identified this is when Facebook was trying to maintain huge amounts of data which is in HDFS, and they want to maintain they want to work with some queries just like we work with SQL queries in RDBMS. That is where they identified the need for such a platform. Then Hive, again it has come from Apache and it is one of the projects of Apache. It is a general purpose scalable data processing platform. Now let us talk about what are the internals of Hive, what do we have, what features does it support and all. Installing Hive, how do we do that? It works on the workstation and converts every SQL job into a series of jobs which are internally converted into MapReduce jobs and executes on Hadoop cluster. And it organizes the data into tables just like SQL tables, and it also provides the metadata which is related to this particular data. So, I will talk about where this data is stored, where the metadata is maintained, what are the operations we can perform, where are the similarities with SQL, etc. And metadata, as I told, which is the tables, schemas and all, everything will be maintained for every database. And that will be maintained in something called as metastore, and actual data is maintained in HDFS. Now, how do we install Hive? Follow these steps and we can install Hive. And once we install Hive, we will get something called as Hive shell, wherein just like you interact with SQL, you can interact with Hive shell also. So, the shell is the primary way with which we interact using Hive commands, and we call those Hive commands is Hive QL, stands for Hive Query Language. It is a similar, it gets the analogies from SQL, and we have various influences. Once we are thorough with SQL, Hive Query Language should not be a tougher thing for us, right? Now, first for example, I want to see what are the tables that are existing. Just like SQL command, you can give near the Hive shell show tables. So, if at all there are no tables initially, it will just come back to OK, meaning the command is successfully executed without any errors, and it will also show you the time taken for executing each and every statement. Like SQL, Hive query language is generally case insensitive, so it does not distinguish between uppercase and lowercase letters, and the tab key will automatically complete the Hive statements. So, you type something and press the tab, the command will be completed. And whenever you are working with a fresh install, the command takes a few seconds to run as it lazily creates the metastore of the database on the machine. We can also run the Hive shell in non-interactive mode with -f. -f, you can try to put all the commands you want to execute, put them in a file, and that file can be submitted here. You can work non-interactively. And for short scripts, we can use -e option to specify the commands inline, and always generally the Hive query language statements terminate with a semicolon, but when we are using short scripts with -e, semicolon is not mandatory. So, say for example, if I give Hive -e select star from dummy, dummy is a dummy table from which if you want to execute, it will execute whatever data you have, the time, everything will be shown to you. Now, one way of populating a single row table, as I mentioned in the previous session, just like SQL has a system defined table with single row, single column, we call it as a dual. Here we are using it as dummy, right? Echo X into the file. So, you want to store X into the file and you want to create a table. How do you want to create a table? Hive -e. The moment you are working with -e, it means you are just working a short script. What is the script statement you have? Create table dummy with what attribute? Value string. You are just using one attribute called value whose data type is string. Then load data local in path, whatever is the path of this file, text file, you are saying load it into which table? Dummy. Overwrite into table dummy. So, whatever is the previously existing data will be overwritten with this particular file. So, both interactive, non-interactive mode, Hive will print the information onto the console. What information will it print? The time taken for executing the query during the course of operation. Now, you do not want to see the timing operation, how much time it took to execute the query. So, you can try to suppress that message using -s. -s is an option to suppress the messages coming from the query execution. So, you can try to suppress that using -s. So, Hive -s -e. -e is for shortcut execution. What is the query we are trying to execute? Select star from dummy. What do we have in that? The single character X. Now, if you observe here, it will not show you the time taken for execution. Now, other useful Hive shell features include you can execute the commands on the host operating system by exclamation prefix to the command and the ability to access HDFS file system using the DFS command. Now, let us try to work this with an example. How do we run a query on the weather data set? First step is to load the data into Hive's managed table. Please mind the word managed table. Very soon I will be talking about what do we mean by managed table. Here we will have Hive use the local file system for storage. Just like RDBMS, Hive organizes its data into tables and we want to create a table to hold the weather data set. How do I give this statement? Create table, table name. Are we going similar to SQL? Yes. Create table, table name. What are the attributes you want to maintain? You need to specify. I want to maintain 3 attributes. I am just using the same example of year, temperature, quality code. So, I am creating a table called records with 3 attributes. I specified the 3 attributes and their data types. Then, after create statement, what else is to be given? Row format delimited. What do we mean by this? Whenever I am trying to store this data, how it will be stored, I will show you. Row format, every row will be delimited. I have separators between the fields. If you are specifying this, what are the field separators? Fields terminated by tab space. So, this file is a tab separated file. Just like we have CSV files, this is a tab separated file. The first line declares a records table with 3 columns: year, temperature and quality. Next, we can populate Hive with the data. This is just a small sample for exploratory purpose. So, I have just shown a sample data, not the exact weather data set. So, I will show you this one. How do we load the data into the table? What is the name of the table we have created? Records. Now, how do we load the data? There is a statement in Hive query language, load data local in path, local, search in the local drive. You need not search in HDFS and all, directly search in the local drive. So, load data local. What is the path of the data? in path, specify the entire path of the file, overwrite, if at all any previous data is existing in the table, please overwrite into the table. What is the table we have created? Records. So it will try to load the text file sample.txt into records table. So the same thing is explained here. Now I want to see, after this statement is executed, try to understand. In this example, we are storing Hive tables on the local file system. fs dot default fs is set to the root directory. In the file system, the root directory. So tables are stored as directories. Whatever name we have given here with the table records, that will be stored as a directory. It will be a folder, right? Whatever is the name. What is the name of the table? Records. So in the file system, you will find a folder called records. Into that, which data are we loading? Sample.txt. So in the folder, you will find a file called sample.txt. Try to see this one, where these tables are going default. Tables are stored as directories under Hive's warehouse directory. There will be a default directory called warehouse. So whatever tables we are creating, they are created under warehouse directory. They are created as a folder, right? So if you try to see what is the folder path, root folder, that is /user/hive/warehouse. This is the folder in which now you will find a new folder with the name of the table, that is records, in which you find a file called sample.txt. So if I try to give the listing for this folder, what is the folder path? Root, user, hive, warehouse, in which what is the folder? Records. What is this record? Corresponds to the name of the table. What data did we load into the table? Sample.txt. So if you try to list out this table named folder, you try to get the file name. Suppose I have tried to load 3 to 4 files into this table. In the listing, you will find all those 3 to 4 files. Then in this case, there is only one file called sample.txt, but in general there can be multiple tables. When you are listing out, you will get all the files, and when I query them using Hive query language, Hive will try to populate data from all those files. And why are we using overwrite? Whenever you are working with overwrite, if at all in the folder called records any previous files are there, all those files will be deleted and these new files will be kept into the folder. If you are omitting that overwrite, new files are simply added to the folder. Say for example, before sample.txt I have my file1.txt, my file2.txt, and in my statement, in the load statement, I did not give overwrite. So how many files will be there in the records folder? My file1.txt, my file2.txt, sample.txt. 3 files will be there in the folder. You don't want the old files, give the overwrite clause. Now the data is loaded. How do I try to work with that? Select, just like SQL statement, select year comma max of temperature from the table name records, where temperature value is not an error value and quality is belonging to these 5 values. And how are we grouping the values? We are grouping it by year value, and you got the output like this. And whenever you are working with this, we are seeing it like a normal query, but Hive will transform it into a MapReduce job without the knowledge to the user, and the user feels as if it is executing an SQL query, but internally it executes a MapReduce job. And the ability to execute SQL queries against raw data gives the Hive that power. Now, how do I configure Hive? Hive is configured using XML configuration, just like Hadoop's, and in the configuration there is a file called hivesite.xml which is located into Hive's configuration directory. in this file you can try to put Hive default.xml, which contains all the properties Hive is having default values. We can also override this configuration file which takes care of Hive site.xml by passing --config root folder users tom/dev/hive configuration. So, if you want, you can try to override the configuration file also. And execution engines, whenever you are working with Hive, Hive was originally written to use MapReduce as the execution engine, and it is still the default one. And the execution engine is controlled by the property hive.execution.engine. You can change if you are not working with MapReduce. And to switch the execution engine, suppose you want to change Tej as the execution engine. This is how we set it. Set hive.execution.engine is equal to Tej. And how do we log in? We can find Hive's error log in the local file system, that is the log records. Wherever you are trying to execute Hive, all the records will be written into something called as Hive log, and this is where you will find the file. Hive services, whenever you are working with Hive, the Hive shell has various services. So, type hive-service help to get a list of available services. Most of the time you get the command line interface CLI as one of the service, beeline as the command line interface to Hive which works in embedded mode, and HWI which is the Hive web interface. So, Hive can work in one of these three modes, either command line interface, beeline or Hive web interface, and Hive is equivalent to working with Hadoop jar file. How do we run? Using these jar files. And who is the Metastore? As I told, the data about the Hive databases is maintained in Metastore, regular data is maintained in HDFS, and the data about that particular data, that is metadata, will be maintained in Metastore. So, if you see, this is how the Metastore will be there, three types: embedded Metastore, local Metastore, remote Metastore. So, what are the various Metastores? Embedded mode, it can have only one Hive session open at a time, and trying to start a second session produces the error message. To support multiple sessions, what are we trying to do? We are going for another Metastore configuration, wherein you are trying to work in the which mode you are working, local Metastore mode. If you see, multiple Hive services have been opened simultaneously. Apart from these things, you can also access a remote Hive Metastore which happens in this. So, in the embedded Metastore, single service can work at a point of time. In local Metastore, multiple sessions can run simultaneously. Apart from local and embedded Metastore, you also have the option to access the Metastore which is located in other sites, other clusters. And comparison with the traditional databases quickly, Hive resembles, as I told, it is almost like SQL, but there are slight differences also. The most major difference is schema on read versus schema on write, which I will be talking in detail in the next course of session, and also updates, transactions and indexes. As of now, these features are not part of Hive yet, and they are not at all considered. So, entire transaction management, everything is automatically managed. We do not have a separate consideration for all these things. Thank you.